Hey guys, welcome to DSA-n-Design. Today we will look at how to reverse a linked list and return the new head after reversal. Alright, so what we want to actually do we want to do reverse a linked list and return the new head. Alright, so this is what actually we want to see. We want to do actually solve it, right? Now, how actually do reverse it. So let's take the example and try to understand how exactly, what do I mean to say when I reverse it and what should actually it happen, right? So everything. So let's say I have my no linked list. Let's say I have three nodes here. All right. And this is, let's say, value 10, 20, 30, and this is N1, N2, N3. This is at 1K, 2K address, 3K address. Now this is basically obviously pointing to this, and this is pointing to this, and this is my head node. All right. This is basically before scenario. Okay. Before scenario. Now this is what? This is 2K address. Next is 2K, and next for N2 is 3K, and for this it is null. Okay. Clear? This is very simple, right? This is what exactly is the before scenario. All right. Now, what we want to do basically after that, right? After reversal, how it should look like. Let me take this. Let me show you. Okay, all right. Let me show you how it should look like after reversal, right? So after here I say after reversal, I should still have all these nodes. Only thing is my pointer should be changed, right? So this is N1, N2, N3, right? Now this is 10, 2K, uh, sorry, 1 second. Value will still be same. Let's try to see what the address will change or not. 30. All right. Now what we will do is the pointer will change actually, right? The last one, which was actually pointing to null here, right? Like this last node N3, it will point to this N2, and N2 will point to N1. All right. So the address will be changed now here. See, for this, the address will be what? This will be 2K, because this is 1K, no? This is 1K, 2K, and 3K. These are the address. So now, when N3 is pointing to N2, which means it will, the next for this N3 will be 2K. For this, it will be 1K, and for this will be null this time. All right. And then head will be actually pointing to this. All right. So this is actually I want to do it. Okay. I want to reverse it, and at the end I will return this. So this should be my resultant linked list, and I will reverse the head. Okay. Now let's try to understand basically what is the logic we can do, right? How we can actually do it, right? So let's say I have, we'll take this example itself, right? So 1, 2, and 3. All right. This is my before scenario. All right. N1, N2, N3, 10, 20, 30. Simple, guys, right? And this is 2K, 3K, and null. All right. This is address 1K, 2K, and 3K address. Fine. That's how it is, right? So now what we will do is, this is 2K address, because the next for this is basically this address, na? N2. Fine. What I want to do, let me take a different color actually. Okay. So then that will be making more sense to explain here. Okay. What I want to do is, let me write my code first. Okay. Let me write my code, and then I can explain you how it is working. Okay. Let me write. Okay. 1 second. All right. I will. No. I want to actually. I don't know. Something is not working, guys. Let's try to write some code here. Okay. What I want to say is, definitely, one thing is very clear, that this is singly linked list, and I cannot actually reverse backward, right? I can only traverse from N1 to N2 to N2 to N3. If I need to come back from N3 to N2, this is not possible, because this is a one directional linked list, a singly linked list, right? That's why what we have to do is we have to actually, in this case, we have to do, we have to point n2 to n1, and n1 should be pointing to null, right? This is what we have seen here, right? Okay, one second. So if I can show you here, no, somehow this is not working, no? One second. I don't know what is happening here. One sec. Or maybe I'll take this color. Okay. So let's try to understand here. Okay. What exactly we want to do? We want to actually point this way, right? Because n1 should be pointing to null, n2 should be pointing to n1, and something like this, no? It should actually, after the resultant, it should be like this. Arrow should be like this, isn't it? And this become head actually after this, right? This is what we want to do, correct? So let's try to write a code, and we will see that whether my code is actually doing it or not, right? So I need to take two pointers actually, two nodes actually, okay? Let's say previous. I'm saying previous equal to null first, assigning, and then I am saying current equal to actually head, okay? This is my head for now, right? Just this is my head, okay? Before reversal, right? Now I'll come inside. I have a while condition. I will traverse until this point, right? So I'll say current until my current become null, right? Until I have all the nodes traveled. What I will do is I will do couple of steps actually. So I'll say node nn. I'll say current dot next. All right, current dot next. First line, okay. Second line, I will say current dot next equal to previous, okay, previous value. Now third one is previous equal to current. All right. Now current equal to nn, which is new node actually. And then finally I will say return previous. Now this is the whole code, guys. This is what exactly I have to do. Okay. And this is my function, for example, right? So what I will do is let's try to understand actually one by one. I'll take a different color so that you know it can be very easy to point it. I'll take this color, for example, right? Now let's try to go one by one. Currently, what I'm doing, I'm saying previous equal to null. So I have a previous, for example. Let's say here is my previous. Okay, here is my previous, which is pointing to null currently. And I have current, which is actually pointing to this node, right? This is my head node, right? Now I will check, I will come here, right? I'll come here, I'll come here and I'll check whether my current is not null. Okay, it is actually not null, right? Now I'll come inside and then I will execute this. I'll create a new node, and the new node value, the new node will be actually the current node dot next, which means this new node will store current dot next. Current dot next is what? This is my current dot next. So this will actually, new node will be actually pointing to this particular node. Agree? As part of this particular line, right? As part of this line. Now current is this line, right? Now current dot next equal to previous current dot next. This is my current dot next, which means actually I am going to point to null. Previous is having null value, right? So this is my current. So which means actually my current, this particular node n1 is now pointing to null value, right? Null value, which is what I wanted, right? So first thing is done. Now second, the third step, previous equal to current. What I will do, say this is my previous. Previous is actually currently pointing to null. I will say previous equal to now current. So my previous will come here. Agree? Now fourth step is current equal to nn. Here you see current equal to nn, which means my current will be moving here. So my current actually moving here now, and I will just cancel it. Okay. Now look it very carefully. Now my n1 is pointing here. All right. uh, n1 is pointing to null value, p is here, c is here, and n is here. Now my loop will go back and it will check while condition again. My current is null? No, it's not null. Current is actually pointing to this n2 node, right? So I'll come inside. I will again create one new node, right? My new node actually not creating but actually assigning, right? So new node actually pointing to current dot next. What is current? Current is this. Current dot next is this one, isn't it? So I'll say my new node actually moving to here, right? I'll cut it. Now second line, current dot next equal to previous. Current dot next equal to previous. So current dot next is previous, which means I will actually point like this, right? Current is here, current dot next, which means actually I will be storing here what? Here what I will be storing now after this will be null, right? Next, current dot null, current dot next will be storing to what? It will be storing to 1k, isn't it? Because current dot next and p is where it's at 1k, isn't it? So 1k, got it? Now what will say? Previous equal to current. Now my previous is here, no? I'll cancel it. It will come here actually. All right. Now last step, current equal to NN. My current is gone here. Current will be here. All right. You see that? Now the pointer is actually pointing here. Now again it will go and it will check whether current equal to null or not. Current is still not null. It is at the last node actually, right? I'll come inside. I'll go and I'll store current dot next. What is the current dot next? Correct, current is here. No. What is the next of this particular current? So it is actually null anyways, right? So I'll say my NN equal to what? NN equal to null, right? NN this time is null. Now what I will say is current dot next equal to previous. Now again say current dot next equal to previous. So this will create a link here. Current dot next equal to previous, correct? And what is the value of this one? Current dot next equal to previous. So previous ka what is the value? What is the address basically? It's 2k, correct? Now previous equal to current. Now previous will actually move to current here. So here will be, and this is already here, no? Okay, fine. Now current equal to NN. My current will become NN here, right? Current will actually become NN here, okay? And NN is pointing to what? NN is pointing to current, right? Null actually, right? So which means current actually pointing to null. Now current equal to NN, which means here only, no? So current become null. Now in this case it comes to while loop, check it. Oh, current is actually not null. This condition is false actually. Then I have to come out. The moment it will come out, it will say, okay, I have to return previous. And where is my previous, guys? My previous is here, right? Which is what? Which is actually head node. This is where. So I want the head node and I will return previous, which means I am actually returning to this particular node, which is actually now in this case head. Now you see how beautifully this link is established, right? You see this one, this one, this one, right? So if you actually follow this particular code, then you will be easily able to reverse this linked list, right? Now let's try to actually go and code it, right? Similar way, we can actually code this. So let me try to just code it. What I'll create is, I will actually create, uh, okay, I'll say public static node, because I want to return the head node, right? I'll say reverse linked list. And what I want actually, I want only head node, right? Based on the head node only, I will perform all the operation. Okay. Now, as I said, I will actually assign node previous equal to null, all right, and then one more node current equal to head. Makes sense? Now I'll actually start a while loop. I'll say current is not null. Until then I will actually go and perform certain operations. So first operation I said I'll create a new node, all right, and new node is going to be current dot next, all right. Now, second step, what I'm going to say, I'm going to change the pointer, right? Pointer. So I'll say current dot next equal to previous. Simply. Now I'll say, I will move actually my previous to current, right? Previous to current. Now current node, okay? Current node will move to new node, actually next node, right? That's what we have seen, right? And now this is all done. and at the end I will return actually previous. Okay, this is what we discussed, right? Now let's try to go, and I will just go here in the main. I have how many? I have actually 5 node already created here, no? If I can just run it, you will see it, right? This is how it is, no? 10, 20, 30, 40, right? Now what I will do is, I will actually, mm, hmm, I will store this head node actually. So let's say I'll say head, not head actually, node reverse head, right? Head of reverse linked list, no? I'll just use this reverse linked list and then I'll say head. Okay. This is what I'm giving output, right? And now simply what I will do is I will actually put these lines basically, okay? Linked list after reversal, okay? Before reverse, okay? Reversal. That's fine. Anything you can write here. Now I am going to say what I'm going to actually print head, not reverse head, right? Reverse head. I'm going to print reverse head. Now this will actually show me before reversal, and this will show me after reversal. And so let's see how it actually looks like. All right. Perfect. Let's see. Linked list before reversal is 10, 20, 30, 40, 50. This is the direction, right? That is how it is. Now link after reversal, you see 50 and 40, the arrow key, you see that arrow key is actually going in direction, and this last node 10 actually started pointing, which was actually pointing to 20 before, it started pointing to null. There is no node no after this, which means it's actually null, right? So I have just put this print command, I just put this arrow so that it is more properly visible, right? So that's how actually you can reverse a linked list, right? And I hope that this concept is kind of making sense, right? Because once you actually do once, try to do this using pen and paper, I think you will be able to solve this kind of questions, right? So that's all for this video, guys. And I sincerely hope that this has been very helpful, and we will be adding many more linked list related what you say problem statements in upcoming videos. So stay tuned, and please request you to share with your friends, and also if you are visiting first time on the channel, please subscribe it and support me so that I can feel more encouragement, and I can do more and more video here that can be helpful for everybody. All right, thank you.